Welcome to today's session on exception handling in C++. This is day 22 of our object-oriented programming course, where we will dive into the concept of handling errors, ensuring smoother program execution, and better user experiences. Let's start by understanding what exceptions are. An exception is an event that disrupts the normal flow of a program. They can happen during execution and may be caused by errors like division by zero or invalid input. There are two types of exceptions: logical errors, which are mistakes in your program's logic, and runtime errors, which occur while the program is running, such as accessing invalid memory. Why should we handle exceptions? There are several key reasons. First, handling exceptions helps with error recovery, preventing your program from crashing. It allows the program to continue running after an error occurs. Second, it provides useful feedback to users, helping them understand what went wrong. Third, it keeps your code clean and organized by isolating error-prone code in try-catch blocks. Lastly, it ensures proper resource management like choosing files or releasing memory like closing files or releasing memory when an error occurs. Next, let's look at the try-catch blocks. These are the fundamental constructs used for exception handling. A try block contains the code that may throw an exception, while the catch block catches the exception and handles it. This separation helps maintain the flow of the program even when something unexpected happens. Here's the syntax of try-catch block. In C++, the try block is followed by one or more catch blocks. The catch block catches exceptions thrown in the try block. In the example, we catch exceptions of type std::: exception and print the error message using the what method. This allows us to gracefully handle errors instead of letting the program crash. Let's look at a practical example. Catching a division by zero error. In the code, if the denominator is zero, we throw a std::: logic error. This error is then caught by the catch block, which prints the error message. This is a simple way to handle one of the most common runtime errors. Now let's talk about custom exceptions. While standard exceptions like std::: exception are useful, sometimes you may want to create exceptions specific to your program's need. A custom exception is a user-defined class that inherits from std::: exception, giving you more control over error handling in particular situations. To create a custom exception, we define a class that inherits from std::: exception and overrides the what method. This method returns a custom error message when an exception is thrown. In this case, our custom exception, invalid exception, returns the message invalid input encountered. Here's an example of how to throw and catch our custom exception. In the try block, we throw an instance of invalid input exception. The catch block then catches this exception and prints the custom error message using the what method of the exception class. Now let's move on to an exercise. In this exercise, we will create a custom exception to handle invalid input in a banking application. The goal is to catch errors like negative deposit amounts or incorrect account numbers before they can cause problems in the system. To start, we define the custom exception class invalid input exception. This class overrides the what method to return a specific error message whenever invalid input is encountered. Let's see how this fits into the banking app. Here's a full example of our banking app. The bank account class contains methods for depositing and withdrawing money. If the user enters an invalid amount like a negative value, the custom exception invalid input exception is thrown. The exception is then caught and the appropriate message is displayed. Now we run the banking app with some test cases. In the first test case, we try to deposit a negative amount which triggers the invalid input exception. In the second test case, we try to withdraw more money than available, which again triggers the exception. The program handles both errors gracefully without crashing. To recap, exception handling helps us manage errors effectively in C++ by using try-catch blocks. We can also create custom exceptions to handle specific errors that arise in our program. These tools help ensure our programs run smoothly, even when unexpected events occur. Here are some best practices for exception handling. First, we use exceptions sparingly, only for true exceptional situations. Second, catch different types of exceptions separately for more specific handling. Lastly, always ensure proper cleanup of resources like files or memory, even if an exception is thrown. For further practice, try implementing other types of exceptions like std out of range and add more complex error handling logic to the banking app. You can also expand the app to include file operations or network related exceptions. That concludes the presentation on exception handling in C++. Do you have any questions or would you like to discuss any of the concepts in more detail? Welcome to day 23, where we will be diving into file handling and object-oriented programming. Today, we will explore how to read and write files using objects, as well as the concepts of serialization and deserialization. File handling in object-oriented programming, or OOP, involves reading from and writing to files using object-oriented principles. This process allows you to process data between program executions, making it possible to save complex objects and later retrieve them, even after your program has ended. Two key concepts in file handling are serialization and deserialization. Serialization is the process of converting an object into a storable format such as text or binary. Deserialization, on the other hand, is the reverse process, converting that stored data back into an object. Common formats for serialization include JSON, XML, and binary files. Serialization and deserialization are essential when it comes to saving and loading object data. Serialization converts the object into a byte stream or text format, so it can be easily written to a file. Deserialization reads the byte stream or text back from the file and reconstructs the object allowing you to use it as if it had never left your program. When writing objects to files, the object must first be serialized into a format that can be saved. This serialized data is then written to a file. In real-world applications, this can be useful for storing user data, configuration settings, or game progress in formats like JSON or binary files. Here's an example in C++ of how you can serialize a student object and save it to a text file. We defined a student class with attributes like name, age, and roll number, and then we serialized those attributes to a file using the serialize method. Just as we write objects to files, we can also read them. To do this, the data stored in the file needs to be deserialized. This process converts the stored data back into an object that can be used in our program, making it possible to restore program states or load user data. In this example, we read from a file and deserialize the data into a student object. The deserialize method reconstructs the object by reading the stored values from the file. After deserialization, we can access the student's detail and use them in our program. For the exercise, we will create a program that allows us to save a list of students to a file and later load it back into our program. This will involve serializing and deserializing a collection of student objects, enabling us to store and restore data across different sessions of the program. Here's the solution outline. We first defined a student class with methods for serialization and deserialization. Then we create a student list class to manage multiple students. This class will have methods to save the list to a file and load it back. Finally, we implement these functionalities in the main program. Let's walk through the code. The student class handles the serialization and deserialization of individual students. The student list class manages a collection of students, providing methods to save the list to a file and load it from a file. The main function demonstrates how to add students, save them to a file, and later load and display them. To summarize, serialization allows us to convert objects into a storable format, while decentralization allows us to retrieve objects from that format. File handling in OOP makes it possible to persist data, ensuring that objects can be saved and restored even after a program ends. File handling is a crucial aspect of many real-world applications, especially when you need to maintain object state or save user data. By using serialization and deserialization techniques, we can easily store and retrieve data, making our applications more robust and efficient. Welcome to today's presentation on object-oriented programming in real-world applications. In this session, we will explore how OOP is used in large-scale systems and its role in industries such as banking, e-commerce, game development, GUI frameworks, and web development. Object-oriented programming, or OOP, is a design paradigm that models real-world entities as objects. It helps in managing complexity and maintaining large systems by dividing them into smaller, more manageable parts. By using OOP, developers can enhance code reusability, modularity, and flexibility. Key OOP features like inheritance, polymorphism, and encapsulation are vital in creating scalable and maintainable software solutions. Let's look at a banking system example. In an OOP-based banking system, we can model entities such as accounts, customers, and transactions as objects. For instance, the base class could be account with specialized classes like saving account and current account inheriting from it. Polymorphism will also useful here. Methods like deposit and withdraw can behave differently based on the type of account. This approach simplifies maintenance and allows easy extensions of the system. Next, let's im- let's examine an e-commerce system. In this system, we could have classes like product, order, and customer. These classes represent key entities in the e-commerce domain. Inheritance is useful for distinguishing between different user types such as customers and admins. Polymorphism allows actions like payment processing to differ based on the method chosen, such as credit card or PayPal. This structure supports scalability and flexibility in e-commerce applications. In this continued example of an e-commerce system, we see how various components interact. A cart class may manage adding and removing products, while different user roles like guest and admins interact with the system differently. For example, only an admin would have access to actions like deleting users or managing inventory. This illustrates the power of OOP to create a robust, scalable system where components are reusable and maintainable. Now let's explore an online learning platform. In this example, the system could have classes like course, student, instructor, and lecture. Inheritance allows us to have different types of users like students and instructors, both inheriting from a base user class. Polymorphism comes into play when methods like login have different implementations for each user type. This allows a unified approach to user management while accommodating different user behaviors. Moving on to game development, OOP plays a crucial role in designing game entities like players, enemies, and items. Each game object can be treated as an object with properties such as health, score, and position. For instance, you could have an enemy class with subclasses like zombie or alien, each implementing different attack behaviors using polymorphism. This structure is, also allows easy management and extension of game features as the game evolves. As we continue in game development, polymorphism allows for dynamic behavior. For example, different objects like player and enemy may use the same method such as attack, but the implementation will vary based on the object type. Encapsulation also plays a vital role as each object manages its own state such as health or score, ensuring that the game logic is clean and well organized. Object-oriented programming is also widely used in GUI frameworks. GUI components like buttons, windows, and text fields are modeled as objects. These objects encapsulate their own properties such as position and size, and methods for handling user interactions like clicks or typing. Inheritance allows us to create specialized components such as submit button inheriting from a general button class. This makes it easy to reuse and extend components in the user interface. Building on the previous point, OOP allows for an event-driven approach in GUI frameworks. Components like buttons can handle events like clicks through methods that are defined in their respective classes. This modular approach allows for easy customization and extension. For example, we could have a button class with a clicked method which could be overridden in different subclasses for different buttons action. Object-oriented programming is also heavily utilized in web development. For example, in an online shopping system, we might have classes for user, admin, and guest, each with different permissions. Inheritance allows for the creation of specified user types, while polymorphism ensures that actions like login behave differently for each user role. OOP structures web applications in a modular and flexible way, ensuring scalability and ease of maintenance. Continuing with web development, OOP is crucial for creating systems like a shopping cart. In this system, classes like cart, product, and order are used to manage the shopping process. Operations like adding or removing products are encapsulated within the cart object. Inheritance allows different user roles, such as members or guests, to interact with the cart in unique ways, enabling personalized user experiences. As we wrap up, let's review the advantages of using OOP in large systems. One key benefit is modularity. Large systems are broken down into smaller, more manageable components. Reusability is another advantage, as classes and objects can be reused through the system. OOP also promotes maintainability by separating concerns and keeping code clean and organized. Finally, OOP ensures scalability, making it easier to extend systems as they grow. To recap, object-oriented programming helps in structuring large systems in a way that is easy to manage and scale. It promotes code reusability, maintainability, and flexibility. By using inheritance, polymorphism, and encapsulation, developers can design complex systems that are easier to understand, extend, and maintain. Now, let's put the concepts into practice. Your task is to design a library management system. The system should include classes like book, user, staff, and library. Implement methods for borrowing and returning books, as well as searching for books. Use inheritance and polymorphism to model different user roles and interactions. Share your design with your peers for feedback. Thank you for your attention. To conclude, object-oriented programming is a fundamental paradigm that is widely used in real-world systems. By constructing code around real-world objects, OOP makes it easier to manage complex applications. For further learning, refer to object-oriented design and programming books and documentation. I encourage you to apply these principles to your own projects. Welcome to day 25 of our object-oriented programming course. In today's session, we will be planning and starting to build a mini project, a hotel booking system. This system will cover key concepts of the object-oriented programming such as classes, objects, and methods to create a functional application. Our objective today is to lay the foundation for our hotel booking system. We will be focusing on three key components: rooms, bookings, and customers. We will start by defining the basic structure and relationships between these components, and later we will add advanced features in the next sessions. Before diving into coding, it's important to define the scope of our project. We aim to create a simple hotel booking system that allows users to book rooms, check availability, and store customer details. Our key components are the room, customer, and booking classes. Each will have specific attributes and methods to manage the booking process. Let's now look at the design of our classes. We will need three main classes: room, customer, and booking. The room class will handle details like the room number, type, and availability. The customer class will store customer information, including contact details and booking history. Lastly, the booking class will link customers to rooms and manage the booking process. Let's take a closer look at the room class. It has a few key attributes: room number, room type, price, and availability status. The methods within the room class will include checking availability, booking a room, and releasing a room once the booking is complete. These methods will help manage the core functionality of our hotel system. Moving on to the customer class, this class will store information about the customer, such as their name, contact details, and booking history. We will include methods like viewing the booking history and making new bookings. The customer class will interact with the booking class to create and manage bookings for the rooms. Next, we have the booking class, which links the room and customer classes together. It will store booking details such as the customer making the booking, the room being booked, the booking date, and the duration of the stay. Methods within the booking class will allow us to create, cancel, and display booking details. However, here's an example of how the room class might look in code. We define the room number, room type, price, and availability status as attributes. The methods check availability, book room, and release room will be used to manage the room's booking status. This simple implementation ensures that we can easily manage room availability and bookings. Now, now that we have set up the basic structure, it's important to think about the next steps. We will be focusing on class interactions, where the customer class will create instances of the booking class, and the booking class will manage the relationship between customers and rooms. We will also begin testing the basic functionality such as creating rooms, checking availability, and making bookings. Here's a simple example of how we can test our code. In the main function, we create instances of the room class, check if the rooms are available, book them, and then release them. This testing ensures that our room class methods are working as expected. Before we wrap up, here are a few tips for success. First, start simple. Focus on building the core functionality before adding extra features. Use object-oriented programming principles to keep your code modular and maintainable. Document your code with comments to make it easier to understand, and remember to test regularly to catch errors easily. Finally, build iteratively, adding features as you go. To conclude, by the end of today's session, you should have the basic code for the room, customer, and booking classes. You should also have conducted initial tests to ensure the core functionalities such as room creation, availability checks, and bookings are working as expected. In the next session, we will focus on adding advanced features like polymorphism and file handling. Welcome to this presentation on the hotel booking system part 2. In this session, we will explore the advanced features of the system including polymorphism, file handling, and error handling. Let's dive into the technical aspects of building a robust and scalable hotel booking system. Let's begin with a quick recap of part 1. We developed the core structure of the system with three main classes: room book, booking, and customers. We implemented basic features such as booking rooms, displaying available rooms, and managing customer data. In part 2, we will add we will add more advanced features to enhance functionality and efficiency. Now let's dive into polymorphism. Polymorphism is a core concept in object-oriented programming. It allows us to use methods in a flexible and dynamic way, depending on the object type. For our hotel system, polymorphism will help us handle different types of rooms like standard, suite, and deluxe, each with its unique pricing and features. This approach ensures that the system is scalable and can be extended easily. To implement polymorphism, we first create a base class room that contains a method calculate price which will be overridden by each derived room type. This ensures that each room class can have its custom price calculation method. Let's look at the code snippet for the base class. In this slide, we have derived classes for different room types. Each class inherits from the base room class and overrides the calculate price method to provide its own pricing logic. This allows us to calculate the price dynamically based on the type of room selected by the customer. Next, we move on to file handling. File handling is essential for storing and retrieving data between program sessions. In our hotel booking system, we need to persist customer and booking information. By saving data to a file, we ensure that it is available even after the program exists. We will explore how to write and read data from a file using file streams. Here's how we save booking information to a file. We use the offstream class to open a file in append mode. When a new booking is made, we save the room number and the customer's name to a text file. This ensures that booking data is preserved even after the program ends. To load the bookings when the program starts, we use the ifstream class to read data from the file. The load bookings function retrieves the stored booking information and loads it into the program. This ensures that when users check the availability of rooms, the data is up to date. Error handling is an essential aspect of building reliable software. In C++, we use exceptions. We use exceptions to catch and handle errors. In our hotel booking system, we need to handle invalid inputs, file read-write errors, and other exceptions like double booking. This helps ensure that the system remains stable even when things go wrong. Let's look at how we can implement error handling. We create a custom exception class, booking exception, to handle errors like double bookings. This exception will be thrown whenever an attempt is made to book a room that is already reserved. It ensures that the system handles the error gracefully without crashing. Here we see how to use the custom exception in the book room function. If the room is already booked, the function throws a booking exception. This prevents users from making invalid bookings and ensures the integrity of the system. To enhance user experience, we implement a menu-driven interface. This interface allows users This interface allows users to easily navigate through different options such as booking a room, viewing available rooms, or checking existing bookings. It's simple and intuitive, ensuring that users can interact with the system effortlessly. To handle user input, we use a loop and switch statement. This allows the program to continually display the menu and take input until the user chooses to exit the system. It also ensures that the user can make choices easily and get the appropriate response from the system. After implementing all features, it's time to test the system. We need to ensure that room bookings work correctly, file saving and loading functions as expected, and errors are handled properly. Additionally, we should document the entire system, including class and method descriptions, to ensure the project is maintainable and understandable. As we consider advanced improvements, we can explore more sophisticated topics. For example, we can expand the class hierarchy to include more specialized room types. We can also use more complex file formats such as JSON or XML for better that data storage. Additionally, we could develop a graphical user interface to provide a richer experience for users. To summarize, in this session, we have enhanced the hotel booking system by adding advanced features like polymorphism, file handling, and error handling. These additions improve the flexibility, reliability, and scalability of the system. Moving forward, you can build on this foundation to add more features and further improve the user experience. Welcome to day 27, Debugging and Optimization in Object-Oriented Programming. In this session, we will explore key techniques and best practices for debugging OOP code and optimizing its performance. Let's begin with debugging. Debugging is the process of identifying and fixing errors commonly known as bugs, in your code. It ensures that the program behaves as expected and helps improve code quality and reliability. It's an essential skill for every programmer. In object-oriented programming, we encounter several types of bugs. These include null pointer exceptions, where we try to dereference a null reference, and incorrect use of inheritance or polymorphism. We also deal with memory leaks, where memory is allocated but not deallocated, and logic errors, where the algorithm does not work as intended. It's important to recognize these common bugs to fix them efficiently. Let's look at some common debugging techniques. First, we have print statements. This simple technique allows you to display variable values at different points in the program, helping you understand the flow of control. Another common technique is using breakpoints. By setting breakpoints in your IDE, you can pause execution and inspect the state of your program step by step. Next step through debugging allows you to go through your code line by line. This helps in tracking down errors in more complex sections. Additionally, unit testing is crucial. Writing unit tests for each part of your code ensures that components behave as expected and makes it easier to isolate and fix bugs. Memory management refers to how memory is allocated and deallocated during the execution of a program. Improper memory management can lead to crashes and memory leaks. In languages like Java and C Sharp, garbage collection handles memory management automatically. However, in languages like C++, programmers are responsible for manual memory management, which requires special attention. In C++, memory management is done manually. You use the new keyword to allocate memory and delete to free it. However, improper memory management can cause issues like memory leaks or dangling pointers, which occur when memory is freed and then accessed again. It's essential to handle memory allocation and deallocation carefully to avoid these problems. To help with memory management, C++ provides smart pointers. These include unique pointers, shared pointers, and weak pointers. Unique pointers take ownership of objects, shared pointers allow shared ownership, and weak pointers prevent circular references. Using smart pointers automatically handles memory deallocation, helping to prevent memory leaks. Optimization is about improving the performance and efficiency of your code. It's critical for handling large-scale applications and ensuring that your program runs smoothly. Optimizing your code involves reducing memory usage, improving processing speed, and maintaining clean, readable code. Let's explore some techniques for achieving this. One optimization technique is avoiding redundant object creation. Instead of creating new objects repeatedly, reuse them wherever possible. Another method is reducing method overhead. Frequent function calls can slow down your program, so consider inlining small functions to minimize this overhead. Next, caching and memoization are powerful optimization techniques. By storing the results of expensive computations, you can reuse them later without recalculating. Also, using efficient algorithms is key to optimizing your code. Choosing the right data structures and optimizing algorithm complexity can drastically improve performance. Now, let's look at an example. The first step in debugging is to understand the code thoroughly. Review the provided code carefully and identify where the bugs might be based on the symptoms you observe. Once you have located the problem, use debugging techniques like print statements or breakpoints to identify the exact issue. Once you have identified the bugs, the next step is optimization. After fixing the bugs, review the code to see if there are any redundant operations or inefficient data structures. Look for areas where you can improve performance or memory usage. Here are some best practices. Code reviews are one of the most effective ways to identify bugs early and suggest optimizations. Refactoring is another important practice. Regularly revising your code to improve its structure and efficiency. Finally, profiling tools like gproof or visual vm can help identify bottlenecks and optimize your code further. To conclude, debugging and optimization are key to writing efficient, reliable OOP code. Debugging helps identify and fix bugs, while optimization ensures that your code runs faster and uses resources more efficiently. As you work on real-world projects, practicing these techniques will help you become a more skilled programmer. Welcome to day 28 of your object-oriented programming journey. Today is all about revising and practicing advanced OOP topics. You will be diving deep into real-world coding challenges and enhancing your mini project by integrating advanced OOP principles. We will also take time to review and optimize your work, ensuring that you reflect on your learning process. Let's get started. Let's begin by revisiting some of the core advanced OOP principles. First, we have design patterns. These are reusable solutions to common design problems. Some examples include singleton, factory, observer, and strategy patterns. Understanding these patterns will help you solve complex software design issues effectively. Next, we have the solid principles. These are 5 key design principles that ensure your code is maintainable, scalable, and easy to understand. We will take a closer look at each principle: single responsibility, open or closed Liskov substitution, interface segregation, dependency inversion. These principles are the foundation for writing robust and flexible object-oriented code. Continuing with our revision, let's talk about inheritance. This allows you to create a class based on another class, inheriting its properties and behaviors. But be careful, overuse of inheritance can introduce unnecessary complexity. Next is polymorphism, a concept that allows objects to behave differently depending on their type. We will discuss both compile-time polymorphism through method overloading and runtime polymorphism through method overriding. Finally, we have abstract classes and interfaces. Abstract classes allow you to provide a common base for your subclasses, while interfaces enforce a contract that classes must follow. Understanding when to use each of these is essential for designing clean, reusable code. One of the key concepts in building resilient software is exception handling. In OOP, we use exceptions to manage errors in a structured way. Consider exceptions. Custom exceptions allow you to handle specific errors more gracefully. It's crucial to follow best practices when working with exceptions. This means using try-catch blocks appropriately and avoiding using exceptions for control flow. Here's an example you might create. Here's an example. You might create a custom exception for handling negative age inputs in a user profile system. Now it's time to practice. Let's apply the concepts we have just revised to real-world coding problems. For example, implementing design patterns like singleton and factory in your projects will help you manage resources and create objects more efficiently. Polymorphism and inheritance can be used to solve problems with method overriding and overloading, such as modeling real-world objects like vehicles or animals. You will also get the chance to refactor your code using solid principles, which will improve the maintainability and scalability of your system. As you continue enhancing your mini project, start by incorporating advanced OOP features. Design patterns like the factory and singleton are perfect for structuring and managing different components in your project. Additionally, refactor your code to follow solid principles, breaking down large classes into smaller, more focused ones. Don't forget to implement exception handling to ensure your project can gracefully handle unexpected situations. Let's take it a step further. Add new features to your mini project such as user authentication, logging, and data validation. This will make your project more robust and production ready. If your project needs to handle large datasets, consider implementing caching for better performance. Optimizing your algorithms and reducing redundant code will also help ensure that your project scales well. Once you have added new functionality, it's time to review and optimize. A thorough code review is essential. Check for readability, maintainability, and efficiency. You will also want to focus on performance optimization, especially in areas with high time complexity. Consider adding caching or lazy loading where appropriate. Be sure to seek feedback from your peers or mentors as they as their input can help you make your project even better. Take a moment to reflect on your learning journey so far. Think about the challenges you have faced while grasping advanced OOP concepts such as design patterns or solid principles. How did you overcome those challenges? Celebrate your key achievements like successfully applying these concepts in your mini project. Finally, think about your next steps. What areas do you still need to improve, and how can you continue to grow as a developer? Looking ahead, day 29 will be all about testing your knowledge. You will be taking a comprehensive quiz covering everything you have learned so far. This will help you gauge your understanding of advanced OOP concepts. You will also have the opportunity to practice coding problems and mock interview questions. This will prepare you for the challenges ahead and help you feel confident in your OOP skills. Welcome to day 29, final quiz and mock interviews. Today we will be focusing on reviewing and reinforcing all the object-oriented programming concepts we have learned. We will dive into a comprehensive quiz, work through coding problems, and simulate mock interview scenarios. Let's get started. By the end of today, you will have the opportunity to test your knowledge through a comprehensive quiz that covers OOP fundamentals, advanced topics, and real-world applications. You will also practice solving coding problems and experience mock interview conditions. This will help solidify your understanding of OOP principles and get you ready for interviews. The quiz today will assess your grasp of object-oriented programming, starting with foundational concepts and moving to advanced topics. You will also be tested on your ability to apply these principles to real-world scenarios. Let's take a closer look at what you will be tested on. In the first part of the quiz, you will face questions that test your understanding of core OOP principles, classes, objects, inheritance, polymorphism, encapsulation, and abstraction. This section will check how well you can implement basic OOP concepts in code. The next set of questions will challenge you with more advanced OOP concepts, including design patterns like singleton and factory, as well as solid principles. You, you will also need to demonstrate your understanding of memory management and how to handle exceptions in your code. In the final section, you will tackle real-world application problems where you will design class hierarchies, identify relationships like has-a and is-a, and model systems like hotel booking or inventory management systems. This part will test your ability to apply OOP in practical scenarios. After completing the quiz, you will work on coding problems that range from basic to advanced. These problems will help you practice implementing OOP principles in different situations. Let's explore the different levels of coding challenges you will encounter. First, you will begin with basic OOP problems. These problems will test your ability to design classes with attributes and methods, implement inheritance, and demonstrate polymorphism. The goal here is to solidify your grasp of the building blocks of OOP. Next, we will move to intermediate level problems. Here you will apply design patterns like singleton and factory and work with abstract classes and interfaces. These problems will help you practice using OOP principles in more complex scenarios. Finally, you will tackle advanced OOP problems. These challenges will focus on dynamic memory management, exception handling, and more complex uses of OOP concepts like dynamic polymorphism and deep cloning of objects. You will need to demonstrate your ability to optimize code while ensuring its correctness. Mock interviews are a great way to simulate the pressure of a real technical interview. In this part of the day, you will practice solving coding problems and answering OOP design questions in a timed environment. This experience will help you become more confident in explaining your thought process. During your mock interview, You may be asked to design systems like a bank account or file management system. You will need to demonstrate how to implement OOP principles like inheritance and polymorphism. Expect to explain your approach and discuss trade-offs in your design choices. In addition to technical questions, mock interviews often include behavioral questions. These questions assesses your problem-solving approach, communication skills, and your ability to handle challenges in a collaborative environment. Practice articulating your thought process clearly and confidently. Mock interviews often have strict time limits, so managing your time efficiently is crucial. Focus on writing clean, efficient code while explaining your approach. If you are unsure, it's always better to ask clarifying questions than to make assumptions. Here are some tips for success. Stay calm and focused throughout the quiz and mock interviews. Think out loud to demonstrate your problem solving process. Practice regularly to improve your coding speed and clarity. And most importantly, enjoy the learning process. By the end of day 29, you will have completed a comprehensive quiz, solved coding problems, and participated in mock interviews. This will leave you well prepared for technical interviews. Remember, OOP is all about practice and clear communication. Keep honing your skills and you will be ready to succeed. Welcome to day 30 of your object-oriented programming course. Today we will focus on showcasing your learning journey. By the end of this session, you will have the opportunity to present your mini project, reflect on what you have learned, and create a portfolio entry that highlights your skills in OOP. Let's dive into these exciting activities. Let's start with the first step, presenting your mini project. The goal here is to demonstrate what you have learned through this project. When presenting, make sure to highlight the problem your project solves, the design and architecture, and how object-oriented programming principles were applied. Showcase the core functionality and the features that make your project unique. When presenting your project, focus on the following key aspects. First, explain the problem your project solves. What real-world issues does your system address? Next, describe the design and architecture of the system. Discuss the classes, attributes, and methods you used. Then emphasize the advanced features such as polymorphism, file handling, or exception handling that you have integrated. Don't forget to talk about the challenges you faced and how you solved them. Finally, consider discussing any future enhancements you envision for the project. Now, let's move on to the reflection part of your journey. Reflecting on your learning process will help consolidate your knowledge and allow you to see how far you have come. In your reflection, you should cover your initial expectations, the key things you have learned, the challenges you encountered, and what growth you experienced. This is an important part of your learning process. Start your reflection by discussing your initial expectations. What were your goals at the start of the course? What skills or concepts did you hope to learn? Understanding your starting point will help you measure your growth and give you a clear view of your progress. Next, focus on the key learnings from the course. What were the most valuable concepts you picked up? Perhaps it was understanding the core principles of OOP, like inheritance, polymorphism, and encapsulation. Or maybe you gained new coding techniques. Reflect on how these learnings have impacted your skills and shaped your understanding of object oriented programming. Every journey has its challenges, and OOP is no different. Think about the most difficult problems you faced during the course, whether it was understanding a complex concept or debugging a tricky issue. These challenges have contributed to your growth as a developer. Reflect on how you overcame these obstacles and how they helped you improve your skills. In this section of your reflection, talk about the skills you have gained. You have not only learned how to program in a object oriented style, but also how to think critically and solve complex problems. Finally, share your future goals. What would you like to learn next in the realm of software development? Maybe you are interested in learning design patterns or contributing to open source projects. Now let's shift gears and focus on creating a portfolio entry. A well-crafted portfolio entry is a powerful way to showcase your skills to potential employers or clients. Your portfolio should highlight your project's features, the technologies you used, and how you applied OOP principles in your work. A strong portfolio will demonstrate your problem-solving abilities and your technical knowledge. Start your portfolio by summarizing the project. Provide a clear and concise description of the project's purpose. What problem does it solve? Be sure to also mention the main features or functionalities you implemented. This will give potential employers a good understanding of what your project is about. Next, list the technologies you used in your project. Be sure to mention the programming languages, tools, or frameworks you leveraged. This helps to show the technical breadth of your skills. It's also a great way to highlight your experience with industry standard tools and technologies. One of the most important aspects of your portfolio is demonstrating the OOP principles you applied. For example, explain how you used inheritance to create a hierarchy of classes or how polymorphism allowed for flexible methods calls. Make sure to showcase how you used abstraction and encapsulation to make your code more modular and maintainable. To further demonstrate your skills, include relevant code snippets in your portfolio. Choose examples of code that showcase your understanding of OOP concepts such as class definitions, method implementations, and object interactions. Briefly explain each snippet so that potential employers can understand the logic behind it. Every developer faces challenges during a project. In this section, talk about any hurdles you encountered while working on your project. Whether it was a tricky bug or a design decision, discuss how you tackled these challenges and found solutions. This shows problem solving skills and resilience. A picture of A picture is worth a thousand words, so don't forget to include screenshots or a live demo of your project. If your project has a user interface, include clear and professional screenshots. If possible, provide a link to a live demo or a video walkthrough to give potential employers a hands-on experience with your project. To make your portfolio stand out, add a personal touch. Be clear and concise in your descriptions, but also give some insight into your thought process. Explain the design decisions you made and the reasoning behind them. Update your portfolio regularly with new projects and improvements, and ensure that it looks professional and is easy to navigate. Preparing for real-world applications is crucial as you transition from learning to applying your skills in professional environments. Keep building projects to refine your abilities. Contribute to open source projects to gain feedback and collaborate with others. Prepare for interviews by practicing explaining your projects and the OOP concepts you applied. Congratulations on completing the course. You have built a mini project that demonstrates your proficiency in object-oriented programming. But remember, this is just the beginning. Keep practicing, continue learning, and apply your skills in real-world projects. Your OOP journey has only just started, and the future is full of exciting opportunities.